This is Lesson 117 in Saxon's 3rd edition, Algebra 1 book. This lesson is on direct and inverse variation squared. So it's sort of a continuation of Lesson 113 on direct and inverse variation. The only difference in how you'll solve it is that one of those variables is going to be squared. All right, so look at the different statements and how those are written out. The weight of a body varies inversely. Now that tells us division with the square of the distance to the center of the earth. So the weight, W, equals K, the constant, over D, the distance squared. The distance required to stop is directly proportional to the square of the velocity. Directly proportional means it's going to be a multiplication setup. So D, or distance, equals K, the constant, times velocity squared. The price of a diamond varies directly as the square of its weight. So P, price, equals weight squared times our constant. All right, the strength of the field is inversely proportional to the cube of the radius. Inversely tells us it's going to be a division setup. So S for strength equals K for constant over radius cubed. Now, this is not squared, it's cubed, but that's how you would set it up because you're going to have to cube that. All right, so let's look at your example problems here. In the first one, it says the distance required for an automobile to stop is directly proportional. All right, so that's a multiplication setup to the square of its velocity. So you've got distance and velocity is going to be squared. So that's how you set that up. If a car can stop in 200 meters, so that's your first distance, at 20 kilometers per hour, what will be the required stopping distance at 28 kilometers per hour? Well, first, again, you've got to find K, and 20 squared is 400. So when you divide by 400, you get 1/2, or 0.5, as your constant. So then you say D equals 0.5 times the velocity squared. Well, 0.5 times 28 squared is going to be 392 meters. In example number 2, the distance a body falls varies directly, again that's going to be a multiplication, as the square of the time that it falls. If it falls 144 feet in 3 seconds, how far will it fall in 10 seconds? All right, so we write our equation out as a multiplication equation. D for distance equals K times T squared, time squared. All right, so if it falls 144 feet, that's our first distance, times K equals K times 3 squared, which is 9. And then if we divide by 9 on both sides, we find that K is going to be equal to 16. So then we say D equals 16 times T squared. We're going to change the time from 3 to 10 seconds. And 10 squared is 100 times 16. The distance is going to be 1,600 feet. All right. Number 3 says the weight of a body on or above the surface of the earth varies inversely, so that's division, with the square of the distance from the body to the center of the earth. All right, so our step 1, we write out our equation, W for weight, D for distance squared, and then K for our constant. So in our original, if a body weighs 10,000 pounds, that's the weight, at a distance of 5,000 miles from the center of the earth. All right, well, our distance is going to be squared. So you're going to have 5,000 squared times 10,000. And that's going to be a really large number, so we're going to write it in scientific notation. 25 times 10 to the 10th is what our K is going to be. So in step 3, we're going to change our distance from 5,000 to 50,000 and try to find out what the weight is. So we have 25 times 10 to the 10th as our constant, and then if we write 50,000 squared, we're going to write that in scientific notation. That would be 25 times 10 to the 8th. So we have 25 times, let's see, 25 times 10 to the 10th divided by 25 times 10 to the 8th would be 10 minus 8. So 25 times 10 to the 2nd. So our weight then is going to equal 100 pounds. And if you're wondering how we got this 100, 25 divided by 25 is 1. And then 10 minus this 8 is 2. So we really have 1 times 10 squared, which is 100. Okay, that's how we got that. All right, let's do our practice problem, and then we'll be finished. The weight of a body on or above the surface of the earth varies inversely with the square of the distance from the body to the center of the earth. If a body weighs 50,000 pounds, so that's the weight. Now, let's set this up. Weight equals K over distance squared. All right, if a body weighs 50,000 pounds at a distance of 6,000 miles, so we have 6,000 squared, how much would it weigh 25,000 miles from the center of the earth? Okay, so we're going to have to do our math here to solve for K. Okay, so this one actually required quite a bit of math and going in and changing numbers, very large numbers, to their scientific notation equivalent, and then working with those numbers. So I've done all that, and we'll talk through it. So 50,000 is 5 times 10 to the 4th. 6,000 squared is 36 million, which breaks down to 3.6 times 10 to the 7th, which would be 18 times 10 to the 11th, or 1.8 times 10 to the 12th. So we take that, this is our constant then. What would the weight be if the constant of 1.8 times 10 to the 12th is divided by 25,000 squared? 25,000 squared is 625 million. Now we're going to break that down because there's so many zeros into its scientific notation equivalent, which would be 6.25 times 10 to the 8th. Then from there it's fairly easy to do the math. You do 1.8 divided by 6.25 and you come out with 0.288. And then 10 to the 12th, if you move this up, it becomes minus 8, leaves us with 10 to the 4th, which means we're going to move this decimal place 4 places. So that would mean that the weight then would equal 2,880 pounds. So there it is. I don't think this lesson's going to be too hard. This may be the most difficult part about it, is getting all these larger numbers into scientific notation, but that's why we've already learned how to do that. so that we could work these larger number problems. Good job. I'll see you next time for lesson 118, completing the square.